Welcome back, everyone. You just learned how to do classless subnetting, VLSM. So this should be a cakewalk for you. Or it could be I'm throwing a screwdriver into subnetting, because now we're going the opposite way. What is route summarization? And there seems to be some sort of a confusion between route summarization and when we get into the distance vector routing protocols that I tell everybody to put no auto summary. And I get, hey Laz, but isn't it a good thing to summarize? Most definitely is a good thing to summarize. When we're advertising these summary routes that include all these networks in there. That way your core router, right, has less to look at because all those networks are encompassed in there. Route summarization. When we're talking about our routing protocol, such as RIP version 2 or EIGRP, where they have where you have to put no auto hyphen summary, it's different because the routing protocol will summarize automatically to the class full boundary. Now I don't want to get too details in it because we're not talking about routing protocols, but I want to make a distinction that the no auto summary command and route summarization are two separate entities. Because if you do not put no auto hyphen summary in EIGRP or RIP version 2, and you're running an entire network with a class A or a class B, it will not know where to send the information. All right, so route summarization is completely different. And I will actually show you the command that you would use to advertise that summary route to a core router. And much later in the course, you will have a summary lab to do in order to reduce the number of entries in that core router, right? That Cisco 3-layer model. That core router, we want to burden it with so many entries. So one of the ways we can do that is to do route summarization. Now, route summarization, just like VLSM, has its rules, right? It has its rules. According to route summarization rules, you should, I'm not going to say you must, I'm going to say you should. You should start with an even number network. That's not an even number network, that's an odd number network, right? 1.0. And you should have an even number of networks, which I don't. I have 3 networks, not 2 or 4. Now, in the certification exam, you do not care about that. I'll say it again, just in case some of you say, he didn't say that, did he? Yes, I did. You don't care. Because what they're going to do in the exam, they're going to give you a bunch of networks, and you need to summarize them. Period. Whether they're odd, even, or whatever it is, you need to know how to summarize networks. That's it. Don't worry about that they're contiguous, discontiguous, or whatever it is, because that's another rule. If you're going to summarize networks, they should fall in a contiguous order. But again, ladies and gentlemen, our focus is to take a certification exam. And if in the certification exam they tell you, hey, I need you to summarize these networks, you will summarize those networks, regardless. And they're usually going to be in a contiguous order anyway. Now, I know on the internet there's many ways to go ahead and summarize, some of them using exponent values and what have you. And it's very simple and easy and quick to use. But it does not always work. And how can I dare say something like that? Because I used to use that method, okay? And when I would put, at one point, I started putting in the advertised summary route in the router, and my router screamed at me and said, you are crazy. I'm not going to accept that. That's a wrong mask for what you're doing. I was like, what? So Cisco states, do it in binary. Binary. You will always get the same answer. The the right answer, the correct answer. Now, some of you may be saying, my God, in binary, really? You're not going to get big numbers to turn these things into binary, and you're going to see how easy it is. And after you get practice with it, you're going to be doing the first network, the last network, and then you'll know what the summary address will be. Like I said, repetition breeds retention. At first, when we learned our timetables, we're like, oh my God, what is 9 times 7? I knew it yesterday. My God, I knew what 7 times 9 was, but 9 times 7, it just confuses me. And we remember our times tables. And then we went on and on and on, calculus, algebra, all this craziness. Okay, we went on and we learned it. So you'll learn this. Okay, so we're going to summarize these 3 networks. The interesting octet that we're going to be looking at is the third octet. So we're going to go ahead. Let me give me some space here. Okay, I thought I had space there. Okay, there we go. All right, so we're going to go ahead. We know that the interesting octet is the third, so the first and second remain the same. Space, space, x dot x, right? I'm going to copy that. Control C, space, space, Control V, space, space, Control V, right? This is called pure laziness, right? No. Now, I need visualization. So I'm going to put my bit values. 64, 32, 16, 8, 4, 2, and 1. And then I'll put the fourth octet later. All right, so you can have that visualization also. So I put the first 3 octets. Now let's turn that third octet into binary, which as you can see is not that difficult. 0, 0, 0, 0, 0, 0, 0, 1. Now 0, 0, 0, 0, 0, 0, 1, 0. 0, oops. 0, 0, 0, 0, 0, 1, 1. Oops. 1. Right? And then we have our fourth octet, obviously. And we'll put it really separate. 1, 2, 3, 4, 5, 6, 7, 8. Because it really doesn't do anything in this scenario. All right, so you can visualize the 4 octets. Now what you're actually doing is the default line is right here, right? Because you have 3 separate Class C networks. They're working, you have the CIDR 24, so the line is actually right here. So what we're trying to do, instead of subnetting, we're supernetting, or we're summarizing, we're bringing the line to the left. Something that I always said you don't do. So anytime you see a Class C, right, because I identify it by the first octet, Class C network that has a mask that's less, that's smaller than a slash or a CIDR 24, you know, or is a pretty good hint that that is a summarized address. All right, so how do we move that line over? Well, what we do is we go from left to right. And we look for the uncommon bit values. And what does that mean, uncommon? Well, in this column right here, they're all common with each other, right? They're all zeros. 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 Aha! Zeros and ones. Well, they're not common to each other. If there will be all ones, it will be good to go. If there will be all zeros, they'll be good to go. But they have a combination of zeros and ones. Therefore, we draw our line right there. Where's my line? That's the wrong line. Line right there. Let's bring this over here. Space, I think. No, I'm just making a mess out of all this. Again, I do it. Okay. Bring it here. Line. Bring it down. Line. Let's make it look pretty. Okay, and delete. All right, so we have our new line. Our original line was here. That was our original line. But now our new line, or our new mask, I should say, is over here. which is a 22, right? Because we got 8 bits on right there. We got 8 bits on right there. That's 17, 18, 19, 20, 21, 22. So we have a slash or cider 22. That is our new mask that will encompass all those networks. So now, what is what's called the summary address? What numbers do I put? Well, first 2 octets are the same. But what do I put in the 3rd octet? Well, you look between the line that you just drew up to the 3rd octet, they're all zeros. So it's all off. 0. And the 4th octet, obviously, is all zeros. Therefore, 0. That is the summary address. And this is exactly what you would advertise. All right. And how would you advertise something like this? And I'll use EIGRP because your packet tracer only supports EIGRP. That does not mean that you can't do it with other protocols. You sure can. All right. But for the packet tracer, EIGRP is the one that you will use. So when you're advertising the summary address, you're advertising it more likely to a core router to reduce the amount of entries in that routing table. Therefore, you would say IP summary. I think my spelling is correct. I usually do a lot of tabbing. Address, IP summary address, the routing protocol in use, the autonomous system. All right, let's just call it 100. And then the actual summary address, 192.168.0.0 with a 255, 255. What's 6 bits on? 252.0. That is how you would advertise, and it will go through an interface, meaning you actually do this in an interface configuration mode and advertise that summary route to that summary, to that core router. But that brings up a question. Hey Lance, well, how does it know to use that and not the actual protocol that's EIGRP, because that's the protocol in use, to use that protocol, to use the main protocol, because you did configure in global configuration EIGRP. Why isn't it using that? And now why? Because you put it on the interface? It's not the fact that I put it in the interface, because once we do this lab, that you put this and then you look at it again, let's say through the show start or show run, you're going to see that it's going to add a 5 to it. And what that 5 is the administrative distance of a summary route. And what that does is that, if you can't see that, I'm sorry, it adds a 5 to it. You didn't put it, I didn't put it, but when you look at the start, it actually adds it because it is a summary route. And that summary route has an administrative distance of 5. EIGRP has an administrative distance of 90. So who's more believable? The one with the lower administrative distance. Therefore, that core router will pay attention to that advertisement and not the other. Okay, but you'll see when you do that lab. So we'll do a couple more examples just so you get comfortable with it. All right, there's just the first example on that. This syntax that I just wrote up there is an example of how you would use that summary address, because the reason you're using it is to advertise it so you can have less entries in your routing tables, and that is your goal. All right, it's easier to look at, let's say, 100 routes versus 1,000,000 routes. So you want to reduce that because you don't want to burden the router, all right, by looking and looking and looking. I mean, it's just, not feasible. Not feasible. All right, let's do another example. Where am I? Here I am. All right, so let's do it again. 192.168. We'll use bigger numbers. Let's do 100. Let's start with an even number. All right, .0, 192.168.101.0, 192.168.102.0, and 192.168.103.0. Okay. So now we have an even number, right? The rule. We have an even number network, 100. And let's bring this up. All right, so you guys can see that. So we have an even number network and we have an even number of networks. So now that should be able to work perfectly. And let me explain that or elaborate on that because I didn't elaborate on the previous example, and I do apologize for that. If you notice that our original networks was 1, 2, and 3, all of a sudden, now we got 0. So we just added a network to it. So when you have these odd numbered networks and so forth, and sometimes even numbered networks, that happens too. The rule doesn't always work, okay? You have these stray networks that all of a sudden appear in the summary address. There are additions to it. It's just the way it is, all right? It's just the way the bit falls, okay? It's just the way the bit falls. So it's up to you on how you want to go ahead and do that, all right? So let's go ahead and do this, I'm sorry, where am I here? Okay, boom, 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 boom. All right, so let's set this up. So x, what am I doing? X.x, copy that. X.x. Okay, what's going on? It's almost the end, my friends. All right. Then I need my visualization. I need my bit values. So I know what to put for the third octet: 128, 64, 32, 16, 8, 4, 2, and 1. And we'll put the fourth octet when we're done, right? So let's go ahead and put 100 in binary. So that's 0, 64 for sure, 32 for sure, that's 96, 16 too much, 8 too much, 4, hey, that's 100, and then 0, 0. So there's your 100 right there, okay? So, well, already you know that 64 and 32 are always going to be on because you have to get to 100. So that's 96. And you need the 4 on because, okay, how did that get up there? You need this one here because that's 100. Now you need 101. You see that? So 0, 1, 1. Didn't I do a 0, 3? So I know I did. 102. And then I know I did 103. Somehow I got erased. So x.x 0, 1, 1, 0, 0, 1. That's 100, and now we need 3. All right, well, let's put the fourth octet, right? We want that visualization. 1, 2, 3, 4, 5, 6, 7, 8. Let's copy that. Control C. All right, there's your fourth octet. So again, left to right, common bits, common bits. They're all common, all common. They're all the same, they're all the same, they're all the same, they're all the same. Different. We stop right there on the 2 column, right? We have zeros and ones again. So we have a 22 again. Let me see something. I think no, I did right. Okay. All right, so it falls in there again. The line falls right there again. Right? Just the way it is. I'm just making up numbers as I go. All right, so we have again a /22. But what is our summary address? 192.168. What? Remember, our line is right there. So anything beyond that way of the line, if it's on, you got to add it. So, well, 64, 32, and 4, they're all on. So guess what? It's 100. .0. That is your summary address. And that is our beginning address, is it not? My spelling is, wow. I've tabbed so much in the router that I've forgotten to spell. Okay, summary address. That is a summary address right there. All right, and you would advertise it the same way you did the previous one. But now, okay, so we summarize addresses. But sometimes in the test, they don't give you for you to summarize addresses. They actually give you a summary address. And then they'll tell you, hey, what networks or what IPs will be forwarded if you're using this summary address. So you need to know the range of addresses that exist when this summary address. Well, it should be 100, 101, 102, 103. But how will we find out? We will do our same procedures that we would always do. Our line is right here, correct? That's the third octet. Okay, 2 plus 1 is 3. Third octet, 3 plus 100 is 103. .192.168.103. And then we add all these bit values over here. That's 255 plus the 0, that's 255. And guess what? It works out perfectly. We do not introduce any new networks at all. So the rule holds true in this case. You start with an even number network, you have an even number of networks, it works out perfectly. All those networks follow each other. There is no 99 network or 104 network. It's just those networks right there. So that's what you would need to do. They will give you a summary address like the CIDR 22 and the 192.168.100.0, and then they would ask you, well, what networks would be advertised or what IP addresses would be advertised, and you need to choose 3 or choose 2, what have you. You will need to know the range. A broadcast address will never be an IP address that's advertised. A network address, yes. An IP address or a usable IP address, yes. Never a broadcast. Never a broadcast. So this is route summarization. The best method, the method that Cisco prefers, is to do it in binary. Do it in binary. Turn whatever octet you're working in into binary. Draw your line where the uncommon bit values are. That will be your new mask. And then if there's any of the ones that are on, you just add those up and put it as your summary address. And that is it. That is it. So this is route summarization. Will you be asked questions on summarization? Yes, you will. There will be at least maybe 3 to 5 questions on your exam. Well, you will have to either summarize given addresses, or you would have to find the addresses within that summary address. And that's when you would do this number right here, our normal procedures that we would do for subnetting. All right, so we've gone through class full subnetting, we've gone through classless subnetting, and now you've done route summarization. Okay, now you know the secrets. I'll see you in the next lecture.